Hi everyone, I am Darshan Yam from Department of Computer Science and Engineering, Sri Venkateshwara College of Engineering, Bangalore, first semester. Today we are going to discuss about e-waste generation and its management. First, let us know about what is e-waste. E-waste, which means electronic waste, which refers to the discarded electronic or electrical devices and equipments, which includes such as computers, smartphones, tablets, televisions, refrigerators, and many more, which have reached end of their life are no longer wanted by the users. E-waste can also be classified as batteries, circuit boards, and cables. It is characterized by its potential environment and health hazards due to the presence of hazardous material like heavy metals and toxic chemicals. Now, let us know about the significance of the issue. At first, rapid generation. E-waste is one of the fastest growing waste streams globally. As technology advances, people constantly upgrade their devices, leading to a substantial increase in e-waste generation. Next, environmental impact. Many electronic devices contain hazardous materials such as lead, mercury, cadmium, and brominated flame retardants. When improperly disposed of, these substances can leach into the environment, polluting soil and water. Now, resource depletion. Electronic devices often contain valuable materials like rare metals, gold, and silver. When e-waste is not recycled or recovered, these resources are lost and must be extracted from the earth, contributing to the resource depletion. Now, health risk. We'll know detailedly about this later. Now, electronic devices lifespan. Many electronic devices have relatively short lifespan due to rapid technological advancements and planned obsolescence. This means that they become obsolete and are discarded relatively quickly, contributing to the e-waste problem. Now we are going to discuss about types of e-waste. Types of e-waste. At first, consumer electronics, which means smartphones, mobile phones, personal computers, digital cameras. Next, home appliances, which includes refrigerators, freezers, washing machines, vacuum cleaners, air conditioners. Then, entertainment electronics such as televisions, DVD, home theater systems. Then, office equipment such as desktop printers, scanners, fax machines, copiers, and projectors. Then IT and networking equipment such as servers and data center equipment, routers, switches and networking hardware, modems, wireless access points and UPS. Then medical devices which includes X-ray machines, medical imaging equipments, patient monitoring devices, ECG machines, dental equipment. Then last it comes industrial electronics such as control systems, power supply units, electronic testing and measurement devices. Then now we can see the e-waste statistics. At the left it is growth of e-waste in India, and at right we can see the total annual global e-waste generation. Environmental impacts. At first, soil and water contamination. E-waste often contains hazardous substances including heavy metals such as mercury and cadmium, lead, flame retardants and toxic chemicals. When e-waste is improperly discarded in landfills or incinerated, this toxin can leach into the soil and contaminate groundwater. This contamination can harm local ecosystems, affect agriculture and threaten human health. Then air pollution. E-waste can release harmful chemicals and pollutants into the air, contributing to air pollution and respiratory problems. Resource depletion. The product of electronic devices consumes valuable resources including rare and precious metals like gold, silver, and platinum. The constant demand for new electronics contribute to the resource depletion, leading to the increased mining activities, which can result in habitat of destruction and ecosystem disruption. Then ecosystem disruption. The mining of raw materials for electronics can lead to the habitat destruction, biodiversity loss and ecosystem disruption. It affects natural habitats and can lead to the displacement of local communities. Then e-waste dumping. E-waste is sometimes illegally exported to the developing countries where it is processed under unsafe and environmentally harmful conditions, causing pollution and health issues. Next, wildlife impact. Improperly managed e-waste can negatively impact wildlife when hazardous substances enter ecosystems and food chains. At last, we can see data security concerns. Inadequate data wiping and disposal of electronic devices can lead to the data breaches and privacy concerns, potentially harming individuals and organizations. Now let us know what are the toxic substance exposure. E-waste often contains hazardous materials including heavy metals, brominated flame retardants and toxic chemicals. When e-waste is mishandled, dismantled or disposed of improperly, this substance can be released into the environment, leading to the health problems. Then respiratory problems. Open burning and informal recycling practices common in many countries release harmful pollutants and toxins into the air. People living or working in proximity to e-waste processing areas may experience respiratory problems. Then skin and eye irritation. Direct contact with e-waste components and hazardous substance can lead to the skin rashes, irritations and chemical burns. Exposure to the fumes and dust can cause eye irritation and discomfort. Then we'll see lead poisoning. Lead is commonly found in older electronic devices such as cathode ray tube monitors and lead acid batteries, which can cause development delays in children and neurological issues in adults. Then mercury exposure. Mercury, often present in fluorescent bulbs and some electronic components, can cause mercury poisoning. When released into the environment, mercury exposure can lead to the neurological damage, kidney problems and other health issues. Cadmium exposure. Cadmium, which is found in rechargeable batteries and circuit boards, can lead to the kidney and lung damage. Neurological and development effects. Children exposed to the e-waste toxins may experience development delays, learning disabilities, and behavioral problems due to the impact of these toxic substances on the nervous system. Cancer. Long-term exposure to the certain chemicals in e-waste such as dioxins and PCBs has been associated with an increased risk of cancer. Infectious diseases. Inadequate e-waste recycling practices can create stagnant water pools in which water carrying insects breed, potentially increasing the risk of diseases like malaria and dengue fever. Then mental health. Living in an e-waste processing areas and dealing with the adverse health and environmental impacts can lead to the stress and mental health issues among affected populations. Now let us briefly know about e-waste management process. Okay, at first, collection, source separation. Encourage consumers, business and institutions to separate their e-waste from other waste streams at the source. This helps prevent the contamination of other wastes and facility recycling. Collection centers. Establish collection centers, drop-off points or e-waste collection events where people can safely, conveniently dispose of their old electronic devices. Take back programs. Manufacturers and retailers can implement take back programs where they accept old electronics for recycling, where consumers purchase new ones. Then comes transportation. Safely transport collected e-waste to the designated recycling facilities or processing centers to minimize the risk of breakage or damage during transportation. Next, sorting and pre-processing. Upon arrival at a recycling facility, e-waste is sorted into different categories based on the type of electronic equipment. Pre-processing involves the removal of batteries, cables, and non-recycled components. Then comes data sanitization. For electronic devices containing sensitive data, data sanitization process are employed to ensure that all data is securely wiped or destroyed. Then dismantling and disassembly. Trained workers carefully disassemble electronic devices to separate different components such as circuit boards, plastics, metals, and other materials. Valuable components like integrated circuits, memorable modules, and hard drives may be removed for reuse or recycling. Then comes recycling, which means the separated components are sent to the specialized recycling process. Metal recovery. Precious and non-precious metals like gold, silver, copper and aluminium are recovered through smelting or other extraction methods. Plastic recycling. Plastics are cleaned, processed and recycled into new plastic products. Then circuit board recycling. Circuit boards are treated to recover valuable metals and prevent harmful materials from entering the environment. Glass recycling. Cathode ray tube glass from older monitors and TVs can be recycled. Then battery recycling, which means batteries are produced separately for metal recovery or disposal in an environmental safe manner. Then non-recyclable or hazardous materials are safely disposed in an accordance with environmental regulations. Environmental and health considerations. Ensure that recycling and disposal practices do not harm the environment or human health. This includes managing hazardous waste in environmentally responsible manner. Compliance and regulations. Local and international regulations regarding e-waste management, ensuring the safety of workers of the environment. Then public awareness and education. Raise awareness about the importance of responsible e-waste disposal and recycling among consumers, business and organizations to encourage proper e-waste management practices. Then certifications and standards. Some recycling facilities obtain certifications such as East Awards or R2 Responsible Recycling to demonstrate their commitment to responsible e-waste management. Innovation and research. Encourage research and innovation in e-waste management to develop more efficient and environmentally friendly recycling methods. Now let us see about e-waste management challenges. Growth of e-waste. The volume of e-waste is increasing rapidly worldwide as more electronic devices are manufactured and discarded. The constant introduction of the new technologies and production are the reason to this problem. Then toxic components. Electronic devices contains hazardous materials such as heavy metals. We read this previously. Then like informal recycling practices. In many parts of the world, e-waste is informally recycled, often under unsafe and environmentally harmful conditions. This lead to the health hazards for the workers involved in environmental pollutions. Then comes data security. Secure data erasure is crucial when disposing of electronic devices, but many individuals and organizations may not effectively wipe their devices, leading to the data breaches and privacy concerns. Then infrastructure and accessibility. Access to the proper e-waste recycling facilities may be limited in some areas, making it challenging for people to dispose of their electronic devices responsibly. Product design. The design of electronic products can make them difficult to recycle or repair. Planned obsolescence and the lack of standardized components can hinder recycling efforts. Cost and initiatives. E-waste recycling and responsible disposal can be costly. To encourage recycling, there may be need for financial initiatives and or producers' responsibility programs to offset these costs. Worker safety. Workers involved in an e-waste recycling may be exposed to an health risk due to the hazardous material present in electronic devices. Then what are the future trends or technologies? Urban mining. Urban mining involves the extraction of valuable materials from e-waste such as rare metals and precious metals using advanced separation and extraction techniques. Then circular economy principles, efficient e-waste collections, robotics and automation, which means robotic sortings. Robots are being used to automate the sorting of e-waste components, improving efficiency and accuracy. Then data security innovations, advanced data wiping, new techniques and tools are being developed for secure data erasure from electronic devices to address data security concerns. Then e-waste marketplace, awareness and educational tools, mobile apps and online resources are helping to educate consumers about the new environmental and health impacts of e-waste. Global collaborations and regulations. International agreements and initiatives are being developed to the standardize e-waste management practices and combat illegal e-waste dumping. Then we have come to the conclusion. In conclusion, effective management of electronic waste, e-waste is a critical and ongoing endeavor that demands our immediate attention and concerted efforts. There are the key points which you have learnt, like environmental preservations, resource recovery, health and safety, legislation and regulations, consumer engagement, global collaboration, innovation and research. Now, in summary, managing e-waste is a shared responsibility that encompasses environmental preservation, resource conservation, public health protection, and regulatory measures. As our world continues to depend on electrical devices, The proper disposal and recycling of these items are not only necessary but also vital for sustainable future. Through concerted efforts and global collaboration, we can work towards minimizing the adverse effect of e-waste and creating more environmentally responsible and resource efficient society. Okay, finally we have come to the end of our presentation. I hope you all understood the topic. Thanking you all for listening till the end.